Okay, so if I gave you this problem.
No, right here.
Right here. It's in front of the desk.
Okay, somebody can look.
Come here, asshole.
No, kill it with your hands, kill it with your hands, kill it with your hands. Oh my god.
Okay, back to this. How would I solve this logarithm? Any ideas? Okay. We need to try to get the x by itself. The only way to do that is to use our definition. So we can write this so we don't have a logarithm at all. Remember yesterday we said the base of log is the same as the base of the exponential. So it'd be 3 to the second power equals 4x minus 7. And now this is an easy equation to solve. 3 squared is 9. Add our 7. Divide by 4. And x is 4. One thing you need to do on these, you do need to check. With these logarithms, we talked a little bit yesterday, and I told you the base and the argument both have to be positive numbers. So when I say check, I mean just plug this 4 in and make sure you're not going to get a negative in that parentheses. If you do, you would say no solution. So if I plug it in, 16 minus 7, that's positive. I don't have anything to worry about. So 4 is my answer. Let's look at B. So how would I write this one? Okay. To the second equals 64. How do you get rid of a square? Square root. With that, we include square root of 64 is 8. Now, check. The base and the argument both have to be positive. So will both my answers be okay? No, I can't use the negative 8 here. So 8 is the only answer I can use. Let's look at C. So this would be 2 to the third equals 2x plus 1. 2 cubed is 8. Subtract your 1. Divide by 2. All you have to do is make sure, if I plug 7 halves in here, do I get a positive? Yes, so my answer is okay. I'm going to give you guys some. This may be a little trickier, but I think you can get them. Try them. Okay. How would I set up the first one? X to the negative 2 equals 16 over 9. Okay, so we're solving exponentials. Now I'm assuming you probably didn't care for the negative exponent so much. There's several ways we could get rid of this. What'd you do?
Can you turn it to x squared equals 9 over 16?
Yes. He essentially took each side to the negative 1 power. Negative 2 times negative 1 is positive 2. 16 over 9 to the negative 1, that would just flip it. 9 over 16. Okay, there are other ways you could have done it. You could have made this 1 over x squared. and end up cross multiplying and getting to the same point. Once we're here, what do I have to do to get rid of my square? Square root, and we know that includes plus and minus. Square root of 9 is 3, square root of 16 is 4. Now again, we check it and we can't have the negative. Don't be fooled into thinking that you don't need to include the plus and minus, because depending on the problem, you might need the negative at some point. For instance, if this had been like a negative x, then the negative 3/4 would work, but the positive wouldn't. So just be cautious. Don't just always assume the negative won't work. Take the time to check it. So 3/4 is our answer there. Okay. E. How do I write that one in exponential form? You can plug that in your calculator and get an answer. We could even work it out. This just means the 4th root of 16 cubed. 4th root of 16 is 2. 2 to the 3rd is 8. So we get x equals 8. If you plug it in, no problems there, so that is our answer. Last one. So this would be 36 to the x power equals the square root of 6. So these are like the problems we were solving last week. What do I need to do? Common base. So 36, I could change that to 6 squared. A square root is like what power? So I have 6 to the 2x equals 6 to the 1/2. So drop your base, divide by 2, and x is 1/4. In this one, x was what it was equal to. That's the part that can be any number. It can be a positive, a negative, it doesn't matter. So 1/4 is fine. Okay. Questions about these equations? Do we need more practice on those? The second piece that we have to talk about today are properties of logarithms, and we will continue working with these over the next few days. This first slide has quite a bit for you to jot down. This first statement, it's up to you whether you write that or not. I just include it because I've already told you that the base and the arguments all have to be positive numbers other than 1. So maybe you don't need to write that piece. But the 3 properties we need, the product, there's a typo, quotient, and power properties. If you have the log of 2 things being multiplied, we can split them up, do the log of each one added together. When it's division, you can do the log of the top minus the log of the bottom. And when there's an exponent, it can come down in front of your log as a coefficient. These 3 properties you have to know. The ones at the bottom, you don't necessarily have to memorize. We can figure it out. Log base A of 1 equals 0, and log base A of A equals 1. Let's say you completely forgot those. If I said like log base 5 of 1, all that means is 5 to what power equals 1? 0. If I said log base 5 of 5, 5 to what power equals 5? 1. So these bottom ones, if you memorize them, great, but really I just want you to understand that and be able to evaluate it. If you understand what a log is, you don't really need to memorize those because you'll be able to look at it and tell the answer there. So those 3 properties are the big thing. We're going to do a little bit of practice with those properties now. Let's say I asked you to evaluate this. Log base 8 of 2 plus log base 8 of 4. So you might just be able to look at that and figure out an answer. But it might be a little more of a struggle. It's not quite as obvious 8 to what power equals 2. 8 to what power equals 4. We could get there, but it may not be real obvious to some of us. The second thing we can do, as long as these bases are the same, we can use our properties of logs to combine them into one log. What turned it into addition? Multiplication. So I can put these together by doing 2 times 4. So that's log base 8 of 8, and 8 to what power equals 8? 1. So these properties can sometimes allow us to evaluate things that are a little more difficult otherwise. B. This is one that you couldn't do. 6 to some power equals 18, that's not obvious for us at all. But these have the same base, so we can combine them. When you combine them, you only write the log one time. If things are subtracted, how do you put them together? 5. So that's 18 divided by 3. 18 divided by 3 is 6. Log base 6 of 6 is, again, 1. Two more properties that we need. I'm going to put them up here, let you write them down, and then I'm going to talk about them. I told you that the log and the exponential were inverses of one another. And we talked before about how inverses are opposites. They cancel each other out. So what that means is if you have both a log and an exponential with the same base, they're just going to cancel. If I said like 3 to the log base 3 of 5 power. Okay. So the property tells us that should equal what? 5. If we didn't know that, let's say we set it equal to x. This is currently an exponential, right? Every exponential can be turned into a logarithm. If you use the definition, this would be log base 3 of x equals your exponent, which was log base 3 of 5. And so then you can see here, your x would have to equal 5. So that's why it works. So you could always work it out and recreate it, but if you have the base of the exponential and the base of the log the same, they will just drop each other out. So the second one is pretty much the same thing, except I had the log first. So if I said log base 3 of 3 to the 5th. We could even use properties of logs to simplify this. What was that third property that we wrote down? Product, multiplication, and power, right? The power property says if you have an exponent up here, it can go down in the front. So this just represents 5 times what is log base 3 of 3? 1. And we get our 5 again. So that's why they work. So if you forgot the rule, you could still get there. This takes a little bit longer. So far, so good? So if I said 2 to the log base 2 of pi power, what would I get? Pi. We could work it out, but we don't have to. If we remember our properties, we know those things cancel. And so pi is our answer. If I said 0.02 of 0.2. And the negative radical 2, what's this going to equal? The log base 0.2 and the 0.2 would drop out and we just get negative radical 2. So C, everybody tell me, what's that going to equal? 71. All right. What about D? X equals log base 4 of the cube root of 16. There's two different ways of using this, or of solving this. We could use properties, or we could treat it like we've done in previous problems. What's your first instinct if you see this? I'll wait until somebody gets some idea. Okay, can we do the cube root of 16? That's a good option. See if you can reduce that. No. Okay. What else can we try?
Then you could do put a 130.
Okay. Cube root is like a 1/3 power, so you could use the rule and drop the 1/3 down in front. Oops. If I could write that would help. Okay, can we solve it from there? Do you know log base 4 of 16? That means 4 to what power equals 16? 2. So x is 2/3. Could have also done that one just by the definition. 4 to the x power equals the cube root of 16, and then start getting your common base from there like we did on the previous problems. And that would work as well. Okay, so far so good. Last slide. I just want to practice what's called expanding these logarithms. So I'm going to give you some expressions, and I want you to use those product, quotient, and power properties to rewrite this. This will be where we pick up with tomorrow. We'll get into some uglier expressions tomorrow, so we're starting out with some fairly nice ones right now just to try to get those properties in our heads. So if I said log base 7 of 8 times 6, and I told you to expand that, rewrite it, use the properties of logs. We're not evaluating. What do you do if you have things multiplied? Add them. When you do that, I'm going to be a stickler. You have to do proper notation. So you have to write the log base 7 on each. So it's log base 7, 8, plus log base 7, 6. You have to write the base on your log. Log base 6 of 12 minus log base 6 of 5. When you do the subtraction, you're subtracting off the thing on the bottom. So if there were several things on the bottom, you'd be subtracting off all of them. How would I rewrite that? Okay. The cube root is the same as a 1/3 power. So then what happens with the 1/3? Last one. base A of the square root of r cubed s squared over t to the fourth.
Turn it to like 3/2 to like 1/2.
Yes, that's a great option. So what this means is log base A. I'm going to show the steps on how he got there. A square root is like what power? 1/2. So then if you distribute that 1/2 through properties of exponents, you would multiply. So it's r to the 3/2. 2 times 1/2 is 1. 4 times 1/2 is 2. Okay. Let's use our properties of logs to
Where'd you get that 3?
the 3, the cube on my r right
Log
here.
3.
Oh, I don't know. Anything else I messed up? Okay, so let's talk about this r. What would happen there? The exponent would have to come down in front, so we have a 3/2 log base A of r. It is multiplied with the s, so we need to add log base A of s divided by, so subtract, since it's a t squared, what will I put? 2 log base A of t. Okay, so I kind of combined a couple steps at once. The things that were multiplied were added, the thing that was on the bottom gets subtracted, brought exponents down. Just kind of a side note, if I'd also had like an a on the bottom, even though the a and the t are being multiplied, it is still on the bottom of the fraction, so you would have to subtract off the log base A of A. Okay, so anything on the bottom gets a negative in front of it. All right, any questions? Okay, then that's our stopping point for today, and you've got about 20 minutes to work on your homework.